Hi, and welcome to another session of Lean on Me with Bob and Larry. No, I'm just kidding. This is just another one of the tutorial videos for the Matrix class. What I'm going to do is I'm actually going to just run through some basic uses of the Matrix class, some implementations, basically calling methods, creating objects, matrix objects, and we obviously have different types of matrix objects based on the previous video that I created. We have dense objects, we have tri-diag objects, and I'm just going to show you how to pretty much set up and use all of these different types of objects and the methods associated with them. So what I've done is actually created a little test project or the test program that we're going to code and look at the implementation and uses of the class. So this is just a blank project here right now. As you can see on the left here, I've actually included, well, I've added the relevant header files to this project already. You can see the dense header file here, the Morpheus class, which is the matrix class, and the tri-diag header file as well. And I have obviously my main program or C++ file, which I'm going to use to run the program that we're going to create. So what I'd like to do first is like before we do anything else, the first thing we obviously have to do is include these files in our program. So I'm just going to go ahead and include the header files here. Let's include some of the standard library stuff first, like IOStream. IOStream picks it up. Let's include, and now we can go ahead and include the matrix header files. So include, and let's say Morpheus first. Morpheus. Let's get rid of this. That's just like an autocomplete that Xcode does, thinking I'm going to use a standard library. And let's go and include tri-diag as well as dense, so we can test and see how all of them work. Okay, cool. So obviously that's the first thing you have to do. You would never be able to use any features of the matrix class if you didn't include these header files. So since we are going to be using some standard features, we're just going to use the namespace standard, and since we're going to be using the namespace for the header for the matrix class as well, we want to go ahead and include the Morpheus namespace. Cool. So that's pretty much the pre-prep that you would need to do before you actually start coding. So see how we'd create an object and then call the relevant functions for whatever we would like to do. So as we know, matrix objects pretty much the same in code as it is in real life when you're doing it on paper. It's a collection of certain data aspects, and for example, a tri-diag object you can consider to be three diagonals, an upper, a middle, like a main diagonal, and then a lower diagonal. So I'm going to go ahead and create a tri-diag object first before we get into the dense objects. So let's create those diagonals that I just mentioned. So basically in the matrix class, these diagonals are represented as arrays or by arrays. So I'm going to actually declare these arrays. They are double arrays, and we declare an array like so. So let's just give it a little bit of data, some random data. Let's just say 9, 10, 11, 12, 13. Cool. So that's just some random data, part of the main diagonal. I've obviously just created a diagonal of 5 elements here. So that's as big as object is going to be. Now we need to create another, and obviously as you see, I've given it this diagonal a name, or the data array a name of diag. So I'm just referring to the main diagonal as diag. So I'm going to refer to the upper diagonal as diag up. I'm also declare it as array exactly 4, and let's just give this 1, 2, 3, 4, and then pretty much exactly the same for the lower diagonal. Diag low, and let's just say this is 3, 4, 5, 6. Cool. So obviously the upper and lower diagonal has one element less than the main diagonal. Cool. So that's the data for the object that we're gonna create to test with, and now we need, based on the structure of the matrix of the tridiag object, we now need a pointer array that's going to point or help us to point to all this data. So we declare this array like so. So I'm going to call it diag data, and as we said, it's a data array, so we declare it like that. And now we pass into this array, or give it access to these three arrays: diag, diag up, and diag low. Cool. So easy as that. So that's pretty much all the variables or the background structural features that we actually need to we actually going to need to use to create this object. So before we go and create the objects, maybe we should define all the data for a dense object as well, so we can actually see when we do start creating objects, we can actually just pull the data from wherever we need. So the dense, the dense objects, they actually need arrays as well to define their data that's contained within them, but it's a little bit different from tridiag. So these objects, these dense objects, they actually all the data is contained in one dimensional array. Basically, it's just a 1 by however many elements are in this in array, and you just pretty much put all the data in there. So let me explain a little bit better by actually doing it. So I'm just going to call this array data and give it all of its values. So the way that the objects are created, the dense objects are created, they'll actually read off sections of this array and put them into rows. So each row will be, say it's a 5 by 5 array, or let's say it's a 5 by 4 array, 5 by 4 object or matrix. You then have 5 elements being read off at a time and then put into rows 4 times. So for example, if we say 1, 2, 3, 4, 5, okay, and then 1, 2, 3, 4, 5, sorry, 1, 2, 3, 4, 4, 5, 1, 2, 3, 4, 5, and let's give it one more row, 1, 2, 2, 3, 4, 5. Actually, let's make it a 5 by 5. 5, 5. Let's make it a 5 by 5. 3, 4, 5, just so it's easier to see. Okay, so you can see we have 5 groups of 5 numbers, and it's going to read off, based on how we define the object when we create it, it's going to read off that amount of elements in this array and then put them into rows and columns. So the other thing that the dense objects need is a pointer to this array, and must be stored in a pointer array, the same as the tridiag object. So I'm going to call this dense data. So that's my pointer array and it's pointing to data, because that is the array that I'm actually pointing to. Okay, cool. So So what I'm going to do is I'm actually just going to go ahead and create these objects and show you how the constructors work. So a tridiag, for example, um, you'd actually create it like you define the type. You'd give it a name. So let's call it A. And now we're calling a constructor by specifying the code in this way. We're calling constructor. So what this constructor are we calling? We're calling the tridiag constructor. Okay, and well, based on the data that I've predefined up here, this tridiag is obviously going to have to be a 5 by 5 um, matrix. So this constructor, the way it would work would be to actually define how big this object is going to be, and we know it's going to be a 5 by 5 object. It's going to have a size of 5, which is one of the parameters we need to pass into this constructor, and then we have to give it the pointer to those data arrays above, and we do that with the pointer array, which we've defined as diag data. So I'm going to pass it diag data. Cool. And that's pretty much all you need to do to construct a tridiag object. So let's just create go ahead and finish the creation of all these objects. And I'm going to finish it off with the dense matrix object that we've defined the data for just now, and we'll start calling methods and stuff afterwards and show you exactly how it works. So the dense object is very similar to the tridiag object, and we're specifying that we want to create an object of type dense, and I'm just going to call object B. You can call it whatever you want really, and I'm going to now call the constructor, and this constructor is going to be I'm going to call this constructor. So as you can see, there's actually a few constructors that actually came up here. There's one that doesn't have any parameters as an input. There's one that has just a number of rows and number of columns, so int m and int n. And then there's one that has data as well. Now we don't want to just initialize an empty object. We actually want to give it the data because we've predefined it. But you can obviously use the previous one and just create an empty object and then use set of functions to then input the data when it's actually being defined, because there are going to be times when you're not going to have the data on hand to create the objects with that is populated with data already. So for now, I'm actually just going to use the third option, and I'm going to give it a size, and I've defined the data to be 5 by 5, and I've already defined the data itself, and I'm going to do exactly the same um, as we did above here for the tridiag constructor, and I'm going to pass it dense data, which is my pointer array to the data. Okay, cool. So let's close that off. Now I've created a tridiag and a dense object. It's as simple as that. You literally don't have to do much more than that. So what I'm going to do is I'm actually going to now start calling some methods just to show you how using these objects can be can be done. So the first thing I'm going to do is I'm actually just going to print these objects just to show you what it actually looks like, especially the dense matrix, because it might look very having all the data in just one long array, but I want to show you how the matrix class actually puts everything together. So for example, we can literally just call the print print method, and it'll just output it in below here. You can see I was messing around with some stuff before, which is why I already have some data here, but I can actually just clear this somehow. Clear, I don't know, all outputs. Just clear. There we go. Cool. So let's go ahead and print some stuff. So so this is how you go about calling methods of that class on that object, and you'd first state which object you're calling a method on, and I'm going to use A, um, and then I'm going to say dot, which is specifying that you're actually going to be calling a method, and then you literally just call the method that you want. So I'm going to use the method print so that we can see the object itself and what it looks like. And I'm just going to see out just an inline to give it some space. So that's what I've done. I've actually just called the print method for object A, which is the tridiag object that I've created above. And I can do the same for the dense object that we created. Cool. So I'm just going to save and run this. And then you'll see the output below here and what it actually looks like. So as you can see here below, the main diagonal is exactly as we stated, 9, 10, 11, 12, 13. Then the two upper and lower diagonals with its data, and the rest are all zeros. And you can see it's a tridiag object, as you can see there. And look what the dense object looks like. It looks exactly like we've stated. So even though there's one long array with all the data in it, it actually read off based on the 5 by 5 that I stated here. It read off 5 elements at a time from this array, and it stored it like so. So you have every row has 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Great. So that's pretty much the basics of creating objects of these classes and then calling methods on them. And there is a special type of method that I'd like to talk about next. Obviously, as we can see in these classes, all these methods that are defined are pretty straightforward. The set methods, the get methods, the print methods, but there's a special kind of method that we actually have to define based on these operators. The assignment operator, the addition operator, the multiplication operator. And when you define them within a class, it's actually called operator overloading. And you can actually do this because there are times when you might need to multiply two matrices or add two matrices, especially for the iteration techniques that we use within linear algebra, such as Jacobi and things like this. And it becomes useful, or it becomes necessary to actually be able to multiply matrices. And the way we do it is by actually defining the operator overloading within the class. So here, for example, we've defined the assignment operator to be overloaded. And as you can see, all this does is if it passes an object, you're obviously calling it on an object, and that object will obviously be defined on the left-hand side as usual. But instead of placing a period sign or a dot and then calling the method, we literally just specify the operator, and then that would compare it to whatever's on the right hand side. So that's pretty much what we're passing in, and we can see here it needs an object of type dense to be passed in on the right hand side of the assignment operator to be compared to whatever's on the left hand side, or the object that we're actually calling this assignment operator on. And the first thing this does is it actually just for example, for this assignment operator, it compares the two, and if they're the same, it's just going to return the exact same method that you called it on. However, if they're different, it's then going to start setting each element in every single one of those, or not necessarily element in the arrays, but each piece of information or each variable that defines the object on the right hand side. It's going to assign it, or it's going to set the object on the left hand side to have the exact same variables. So and then it'll return it, obviously, and then it works very similarly for the addition operator and the multiplication. So I think it'll be easier to understand if we run through an example and actually see. So obviously, to be able to do that, we'd first need to create another object, and then we'll be able to multiply. So I'm actually creating an object, so I want it to be type dense, for example. Let's just call it C, and call the constructor. Now I actually don't have any of this information just yet. I do know that I'm just gonna, for simplicity's sake, I'm just gonna create a 5 by 5 matrix as well. but I don't have this data array pointer that I actually need. So let me go back and create it quick. So it obviously is same as before. It needs to be a double array. I'm just going to call it data1 array equals. Sorry, I'm not even going to set any values in it because it's just going to be replaced anyway. And I'm going to say it has to be a data array of 25 elements. Okay, and then I'm going to create a double pointer array. I'm going to call it dense data1 array, and then I'm going to give it data1. Okay, so I've passed it in. Now I've defined those, and now I actually have something to be able to use in here. So I'm going to use dense data1. Cool. So I've defined C, but there's nothing in C. And what I'm going to do to be able to demonstrate this is I'm going to say C is equal to B times B. And I'm then going to just put a line in there so it doesn't confuse us. And let's go ahead and run and see what happens when we multiply this. Okay, cool. So we still have the two printed objects from before, but as you can see, we have a whole lot of data here below. So what does this mean really? Well, what this implies is that when we use the assignment operator, it actually, even though I haven't printed anything, it actually does a print, so you can see the data that's being multiplied. But this is not it's not in a very nice form. So I actually want to see what does this matrix actually look like that, after the multiplication is done. And the same as before, we're just going to call the print operator, or the print method. Sorry, what am I doing? See out. Just to see what it looks like. So that's all the data, and when I actually print the object that we used to store the multiplied data in, it actually looks like this. And if we do the maths, because we're basically taking this matrix and multiplying it by itself, it would be this row times this column, which would be 1 times 2 times 3 times 4 times, sorry, um, 1 plus 2 plus 3 plus 4 plus 5, so that you can do the maths and you can actually just confirm. But what you'd see is every single one of these elements is the multiplication of this matrix by itself, and that's operator overloading. And it's just for you to get a feel. That's pretty much what operator overloading does. It actually gives you that functionality. Cool. So that's the basics of the matrix class, and that's pretty much how you'd call and constructively use the matrix class, or practically use the matrix class within a program. Cool. So I hope that's been helpful. There are other videos, so you guys can have a look at. We go into more detail on adding methods into the matrix class and creating methods from scratch, and there are examples used, and you can carry on looking at the rest of these videos for more examples. Cool. Thank you. Bye.